Hello everyone, this is S. Srinidhi presenting my final year project along with Ramesh Kumar M and Shruti S. So the title of our project is Real-Time CNN-Based Worker Fatigue and Stress Monitoring System. So starting with the introduction of our project. So worker fatigue and stress detection system is a very inevitable system in today's world. So our project uses a CNN model which predicts emotions and classifies them into fatigue, stress, or normal states. So it's built using a React front end and fast API for the backend. So it provides live dashboards and analytics. Moving on. So the problem statement for us is the fact that workers in manufacturing areas face a lot of long shifts and repetitive tasks. So current systems do not monitor their emotional strain in real time. So for that, there is a need for a non-intrusive AI-driven solution to detect fatigue and stress early, so that the employers are able to provide with some solutions for their employees. So the main abstract of the project is that it uses AI, computer vision, and audio analysis to monitor the emotions non-intrusively. So we use advanced models like the YOLO V8 model, CNN model, and a transformer-based model. So the results are stored in a MongoDB database and are also shown on an interactive dashboard. Moving on. So the literature review involves the fact that there have been a lot of systems in this particular arena, but our system provides a little bit of nuance and an advanced model because of the fact that it involves multi-phase detection and voice analysis. Moving on. The main issues and challenges that we faced while doing this project is the fact that we need to handle a lot of lighting variations, noise, and industrial environment conditions, which affect the accuracy of the final product. And there is also a lot of personalized calibration of risk scores for each worker, which is again computational complexity. And addressing the privacy and ethical concerns in the workplace monitoring system is also a big task. Moving on, the architecture diagram part will be taken over by Shruti S.
So now let's see the architecture diagram. The front-end ecosystem has the user interface, what the supervisors see. It has React plus Vite. Modern web technology is used to build fast interactive dashboards. Worker card displays each worker's fatigue or stress status. Real-time dashboard shows live updates and trend graphs. Analytics and Reporting Hub generates CSV or text reports using vCharts. Axio's utility handles API communication between front-end and backend. The theme engine switches between the dark and light modes for usability. Then the backend infrastructure uses Fast API, which is a Python framework for high-speed API communication. Centralized inference engine coordinates all AI models and logic. Temporal intelligence processing handles time-based emotion trends using transformers. Then worker tracker deep phase maintains identity persistence, ensures the same worker is tracked across frames. Calibration engine adjusts thresholds per worker for personalized scoring. AI/ML core and temporal intelligence. We use YOLO V8 phase detection, CNN for classifying the emotions, fatigue, stress, and normal. Then transformer model for smooth predictions over time. Stability engine, strain and scoring engine. Then OpenCV hard cascade for as a backup detector for low resource systems. Then we have the database layered MongoDB. It stores the worker ID, emotion, fatigue, stress, timestamps, and alerts. Time series indexing enables trend analysis and historical reporting. There is a 6-step data flow: capture, recognition, perception, temporal smoothing, persistence, and reporting. Moving on to the next slide. These are the system requirements and tools. So for hardware requirements, we need 8 GB RAM, multi-core processor, HD webcam, microphone, stable internet connection, and the GPU that is recommended. Next slide. These are the software requirements. Next slide. This is the algorithm of our project. So the modules and description will be taken over by Ramesh Kumar.
Now we can see the system's module and its description. First module is video capture and data acquisition module. To capture real-time video stimulating webcam through the front-end interface. supports both video and audio input for multimodal analysis. The second module is face detection and pre-processing module. Detects face using ALO-VA for fast and accurate real-time performance. Applies pre-processing techniques such as resizing, normalization, latch, and retinex. And the third module is emotion detection using CNN. Uses a CNN-based deep learning model built with TensorFlow and Keras. Output probability scores for each emotion class. Converts emotions into stress and fatigue indicators for further processing. And the fourth module is multi-person tracking and the recognition module. Uses deep face to identify and track multiple workers across frames. Assigns unique ID for continuous monitoring, enables scalable monitoring in multi-worker environments, and the module is voice stress analysis module, captures audio inputs and processes it using the browser library, generates a voice stress score for each worker, enhances system accuracy by combining audio with a visual analysis. The system module is risk assessment engine, which computes a dynamic risk score using fatigue stress levels and session duration, and it incorporates worker-specific calibration for personalized score adaptation. The seventh module is database model, which utilizes MongoDB for high-speed, scalable storage of real-time historical data, enables real-time data persistence from fast API backend with asynchronous operations. And the eighth module is visualization and the reporting module, which provides real-time dashboard with a live monitoring, plots, stress indicators, and it supports dark or light theme engine for enhanced user experience and usability, which enables data-driven decision-making through alerts, trends, and historical insights. And these are the implementation screenshots of the model, and these are the references of the project. The implementation of our project, and this is the front-end dashboard. Here we can start the camera and capture video lively. On the right side, you can see the data changes based on the live video. Here we can see the stress and the fatigue level. It also detects multi-worker when we have more than one faces towards the camera. Here we can see that there is an audio analysis. It is also used for increasing the accuracy of the stress analysis. After 30 frames captured by the camera through live monitoring, here the temporal transformer will show the results. Here we can see that the voice score is 50%. All these data are stored in the MongoDB database. Here we can see that the temporal transformer shows the result after capturing the difference. This is the dashboard page. Here you can generate report. You can see that there are 100 protocols captured, and the average fatigue is 32 and max stress is 68. Here we can see that the weekly heat map, and here this is the analytics page. Here we can see that the emotions are mapped to the two different labels. One is stress and another is fatigue. And this is the report page. Here we can export the report as CSV file, and we can also export the report as text file also. This recommendation for from an AI called Claude. Here, for this we can reset the data from this entire page.